Today you're going to be learning about segment addition, and as we've talked about in this class, details are extremely important. So if we're talking about segment AB, we're going to name it with the segment bar above it like this. We would say that this is segment AB. That's how we would verbalize that. The difference between this AB and the AB with the segment bar above it is this still means segment, but no segment bar like that means that we are actually talking about the length of the segment. So that's key difference there that we have to pay close attention to, the difference between having the segment bar versus not. One is naming the segment, the other one is talking about its length. So in example 1 here, when I ask you what is AC, it's really asking you what is the length of AC, since there's no segment bar above here. Now when we go over to our segment, we see that from A to B has a length of 11. From B to C has a length of 17. Therefore, if I want the length of A all the way to C, I have to add those two together. That's our segment addition. 11 plus 17 means that AC's length is equal to 28. Part 2 of today's lesson is going to talk about the word between. Betweenness is pretty much exactly what you might think it is, but no more than that. What I mean is, if I'm telling you that point R, is between points S and T, all that tells me is that I have somewhere on this line S, I have somewhere on this line T, but I also have point R on the same line, so it must be collinear. And it does not mean that it's exactly in the middle. R could be right here. If I said that was point R, that's fine. That meets the criteria of something being between 2 points. I could technically take point R here and move it here. It's still between S and T. So when all I'm telling you is that R is between S and T, that's all we know. No more. Okay. Take that and apply it in example 3, where they tell us to draw point D between points C and E. They're asking us to put on this line endpoints of C and E with point D somewhere in between. It does not have to be the middle. If I see the word between, I try to avoid the exact middle because I don't want to trick myself into thinking it's the midpoint or it's in the exact middle. So I might put it a little closer to one of my endpoints. That way I can go back and label what I know. I know that segment DC has a length of 8. So here's segment DC. I will label that as having a length of 8. And I know that segment CE is 21. Since CE is this entire length going through D, it's hard to just label that anywhere like here. And I don't want to label it here because we'll think that's segment DE. So if I'm labeling a segment that has a point somewhere in the middle, I will typically do this. That way I can visually see I'm talking about from here, which is point C, all the way to here, which is point E, has a length of 21. Again, we're talking about segment addition here, but in reverse. The thing we don't know is the length of segment DE. That's what they want. But I do know that if I took my part here, small piece CD, which is 8, I added the medium-sized piece here, which is X, I'm going to get an answer of the entire length of segment CE, 21. We use our algebra to solve that, to find that segment DE has to be equal to 13. That is our segment addition postulate. It states that if B, a point, is between A and C, I have A and I have C and I have B somewhere in between it, then AB plus BC equals the entire length AC. So if I add the two small pieces, I get the big piece. Move on to the second video to start working on some of our examples.